find it learning brown way too fast? It's not just a cosmetic change. It actually tells us a lot about the science happening inside our food. This natural browning might seem like a small inconvenience, but it can affect taste, texture, and even shelf life. In today's video, we're taking a closer look at why this happens, what role enzymes play, and how we can control it using smart, effective methods. Whether you're someone who loves prepping fruits in advance or you're curious about how the food industry tackles this issue, this one's for you.
Brown melanins are formed by the oxidation of phenolic chemicals. These fruits and vegetables darken quickly when exposed to air. This is due to the polyphenol oxidase as the primary enzyme responsible for initiating the enzymatic browning process. It is initiated by the type 3 copper protein, PPO, which has been reported widely in bacteria, fungi, plants, and mammals. Derived PPOs contain a highly conserved catalytic center. This center contains two copper ions termed copper A and copper B that are each coordinated by three histidine residues. PPO can function as either a tyrosinase or chemical oxidase. Tyrosinase can catalyze two different reaction cycles, the first being the orthohydroxylation of monophenols to diphenols with subsequent oxidation of the diphenol to an O-quinone. The second being the oxidation of the O-diphenol to an O-quinone. In contrast, chemical oxidase is only able to catalyze the oxidation of O-diphenols to O-quinones.
Now that enzymatic browning have been introduced and explained, I will now discuss the ways in which we can prevent this from happening to our favorite fruits and vegetables. First on the list is reducing the pH level by squeezing any form of citric acid and vitamin C like ascorbic acid to fruits and vegetables. It will act as an antioxidant, making PPOs less active. Second type of enzyme inhibition is dousing water onto cut fruits and veggies, minimizing its exposure to oxygen. The third way is blanching, which is briefly heating food in order to denature PPO enzymes, making it unable to start browning. And those are the ways we can save and enjoy our favorite fruits and vegetables for later.
In the food industry, common inhibitors include ascorbic acid, citric acid, and calcium salts. These are often sprayed or dipped into fresh cut fruit to preserve color and freshness. In households, a quick lemon juice squeeze works the same magic. This method don't just make food look better. They help reduce food waste, extend shelf life, and maintain quality without heavy processing. So next time you prep fruit for later, remember a little science goes a long way to keep it fresh.
Although polyphenol oxidase inhibitors like ascorbic acid are effective in slowing down browning, there are still some key challenges. One, it is consumer acceptance. Many people are cautious about chemical treatments, even natural ones, especially when they're not familiar with the process. This can affect how well these methods are received in the market. Another issue is the effectiveness and stability of inhibitors. For example, ascorbic acid can degrade quickly when exposed to air, light, or heat, reducing its ability to prevent browning over time. This limits its usefulness, especially in large-scale food processing. To address these concerns, researchers are working on new preservation techniques. These include natural inhibitors from plant extracts, edible coatings that block oxygen, and modified atmosphere packaging. There's also interest in developing fruits and vegetables with naturally lower PPO activity through selective breeding or biotechnology.
In summary, enzymatic browning is a key challenge in maintaining the freshness and visual quality of fruits and vegetables. By understanding the role of polyphenol oxidase and the use of inhibitors such as ascorbic acid, we can better manage this natural process. While current solutions are effective, continued innovation is essential to meet consumer demands for safer, more natural preservation methods. Controlling browning not only improves shelf life, but also reduces waste and enhances the overall value of fresh produce.